Hello, I am Hiba, a TA for COMPSCI 311, and today I'll be covering the RLO that I created for the course, Primer for Proofs. COMPSCI 311 introduces one to algorithms in several areas, such as graph and network algorithms. The emphasis in this course is on designing the algorithm, not coding it. Designing the algorithm involves 4 steps: formulating a clear problem definition, proposing the algorithm, proving the algorithm solves the problem correctly, and analyzing time complexity. In this RLO, we focus on the third step, that is proving the correctness of an algorithm. Proving the correctness of an algorithm requires fundamental understanding of concepts such as induction, what is strong induction, what is weak induction, proof by contradiction, necessary and sufficient conditions, if and only if conditions. While these concepts have been covered in CS 250, the knowledge of translating these concepts to structures such as graphs have not been covered in depth, and this can be challenging for students. We noticed this while grading assignments and midterms, and the teaching faculty thought that a primer or a refresher of these basics and how one can apply these to structures such as graphs can be useful. That's why we created a primer for proofs. This is a document that revises basic concepts of proof of correctness. Each concept is supported with examples. And in addition, we also include the common mistakes a student can make and how they can go about correcting these mistakes. Let's take a look at the document. We first start off with proof by induction. This is a frequently used method for proving the correctness of an algorithm. We cover what weak induction is, what strong induction is. We provide examples of how this can be applied to prove the correctness of an algorithm, and also when a weak induction may not work and how strong induction needs to be used instead. We then move on to graphs and give examples as to how induction can be used on graphs. We also highlight a common mistake that is made while using induction. And we give an example of a false theorem that may seem true if induction is used incorrectly. We then move on to show an example where the theorem is true, but the proof is incorrect because, again, induction is used incorrectly. We then move on to show how the induction step can be rectified. Recursive definitions is an important part of 311, and we cover that over here as well and show how induction can be used to prove properties of recursive definitions. As you can see, the template is uniform. We start with base case and then move on to inductive hypothesis and then the induction step. It's the same throughout the examples so that the students have a common template to follow and that they do not get confused. We then move on to proving if and only if conditions. We describe what this exactly means, how there are 2 parts to these conditions, and how if actually means sufficient and only if means necessary, and how one would go about proving these conditions. We also make a note of a common mistake that one makes, that is just proving one of these 2 conditions. And we also support it with an example over here, again, relating to graphs. We then shared a survey to get feedback about this document with the students. We asked them 3 questions. Will the primer be useful if shared in the beginning of the course? What did they find most useful? And what else did they think could be incorporated in it? We received 15 responses. All of them believed that the primer will be useful if shared in the beginning of the course. For the question, what did you find most useful? The students found the refresher on induction and how it can be applied on graphs particularly useful. They also appreciated the incorrect examples and how to exactly rectify them. And for the question, what else do you think should be incorporated in it? What stood out was a suggestion that proof by contradiction be explained properly and be supported with more examples. So we hope to incorporate this feedback in our next iteration and hopefully share this primer with the next class of 311. Thank you.